Today we're going to walk through a demonstration of the PHEMI central product and walk through how it can be used to unlock complex data sources containing sensitive private information in order for users, whether researchers or analysts, to perform the analysis that they desire to do upon that data while respecting requirements around the de-identification and restriction of that data along the way. The demonstration is going to focus on the following scenario. We're going to have three different sources of data we'll be bringing into the system. This consists of some claims data, which is taken from the CMS Medicare claims dataset that was released a few years ago. This is going to be representative of structured data in the form of a delimited CSV file that's coming in from an external database, for instance. The second source of data is clinical data, which is represented by unstructured text that are indicative of clinical information, for instance, that a physician may take care of or record during the course of a doctor's visits, for instance, or other type of medical visit. The third piece of data that we're going to be working with is diagnostics data, and in this case here, conforms to HL7v3 documents that have been simulated to conform to the blood test reporting that might be done within a laboratory, for instance. All three sources of data do not have actual personal health information in them, but are representative of those respective different types of data, which we'll be bringing into the system. We'll walk through how an administrator is able to onboard this data, is able to specify the protections that must be put in place to restrict access to those sensitive pieces of data, and then apply de-identification protocols to be able to enable more uses of the de-identified data compared to the initial protected information. At this point, we'll flip to an end-user persona, and we'll walk through how these sequence of events enable an analyst, for instance, or a researcher user to efficiently work with this data to then come up with their own insights into the information. Importantly, we'll show how during the initial configuration, our analyst, who will be named Alice, does not have access to any PHI data, but instead works with just de-identified records, versus our researcher named Ev is going to have access to the full set of information and have access to the full data set for her purposes. So the rough time frame or sequence that we're going to walk through here is going to involve the data being loaded. You see samples on the left-hand side here, so we have the claims data as well as our example of our XML lab report information. And over on the right-hand side here, we'll be using Tableau for visualization in this particular example. But when we drill into the information as our Alice analyst view, we're going to see that she sees only de-identified data along the way. The contrast being for Eve, our researcher, same data, same ingestion into the system. But in this case here, when she starts working with the data, she's going to have access to the fully identified information. The sequence of events we're going to walk through, as stated before, we're going to start as an administrator within the system, so the initial part of our data flow. We will go through some configuration of how we're going to allow data to be stored in the system and how it's going to be controlled. We'll then do an actual example of ingesting some data into the system and walk through how it can be unlocked using the capabilities present within the PHEMI system. And then we'll talk about how we're now able to publish this data to Tableau for our analysts to work with. This is the PHEMI Central Management Console. This is the UI you can use to configure and set up the system, as well as interrogate and browse through some of the data. This is a 7-node Hadoop cluster based on the Cloudera distribution of Hadoop running within Oracle's public cloud. And I'm going to begin by logging into the system as Andy, the administrator. Upon logging in, I'm presented with a standard system metrics page that contains information about a variety of the different protocols and configurations, if you will, that are present within the system. This is a demonstration system. It contains a bunch of different varieties of data. By expanding the left-hand bar, I can look at various different pieces of settings I can do, as well as different interrogations I can do within the data, as well as configurations to start to onboard data. The starting place I'm going to begin with today is our access policy. So this is the basis for how data is controlled and accessed within the system. And I'm going to take a look at a specific example of a policy so we can walk through and understand what it does. So a policy is a set of rules, and what this policy is intended to do is to capture and enforce the rules and restrictions around who can do what with data in the system. A single rule consists of three pieces. The first piece is specifying what authorizations must the user have in order for this rule to be applied. In this case here, the rule dictates that if the user has the researcher property, then I can apply this rule to them, and we'll walk through the rest of the rule in a second. These properties are typically pulled out of your Active Directory, so they correspond to properties or attributes of your users within your organization that matter for restricting access to the system. The second part of a rule dictates what they can do. So in this case here, if the user has the researcher property, they're going to be able to both read and export data. This corresponds to querying for the existence of data, as well as actually taking the data out of the system into their analytical environment. In this case here, we're going to be pushing the data into Tableau for the actual analysis to happen down the road. So the researcher is going to be able to both query and export data. And what data are they going to be able to do that with? It's going to be data that has been tagged according to any of these visibilities. So in this system here, we have a variety of different tags that have been configured for different demo scenarios. The two of interest to us are PHI, corresponding to protected health information, such as, for instance, your name, your date of birth, perhaps your social insurance number or social security number, and non-PHI data, such as, for instance, your height, your weight, your hair color, and other non-identifying data. So this first rule says if I'm a researcher, I get to have access to data that is being tagged as either PHI or non-PHI. This list of visibilities is entirely customizable depending on your scenario. In a healthcare scenario, we often encounter PHI, non-PHI, as well as de-identified data, which we'll talk about in a second. But this could also extend to cases where, for instance, I want to capture geographical or source properties of that data, such as, for instance, this data originates from a particular hospital or under a particular research study, or other types of scenarios like that I want to use when controlling access to that data. So that's our first rule in our policy. We build up the policies using multiple rules so that we have more complex access controls to the data in the system. My second rule is very similar to the first, except it only applies to users that have the analyst property. The same actions are applicable. And in this case here, this user does not get access to that PHI data, but instead only to de-identify the non-PHI value. What's wonderful about this approach to access control in data is that it limits and reduces the complexity that often arises in situations where you're using role-based controls to dictate who gets access to data. This approach is very powerful when you have a variety of different stakeholders who have different uses and different requirements for working with this data, such as, for instance, a privileged few, for instance, that might have access to the full set of data versus many other users that have access to less data. And if your access control paradigm might evolve and change over time. So you may, for instance, bring in new additional data that has to be managed in new ways, or potentially maybe regulatory regimes might change over time and you can work with existing data in new ways. This is a very flexible approach to how you can control that access. So this is the policy. This is the one place where you configure this in the system, and this is how we then control access to data in the system. So let's talk about getting data into the system. In PHEMI Central, data is stored inside what are called data collections. You can think of this as being like a folder or a table or a bucket, if you will, where I store a bunch of similarly related data that I want to work with in the system. In this case here, we have a whole variety that have been set up for various different demo scenarios. I'm going to dive in and focus on our lab results data, which is where those XML blood reports are going to be stored. To configure a place to store this data in the system, I just have to go through the specification of a few key properties within the system. Specifically, I'm going to provide some information around the name of this collection so I can refer to it. We have some programmatic generated values that allow me to interact with it automatically. I can provide some information around who are the individuals that are important for the governance of this data. So for instance, the data owner is the only individual that can change the settings we're looking at right now. The privacy officer is the person that's permitted to look at the interactions with the system, the audit of the actual things that introduce into the system. And the institutional owner corresponds to who's actually in charge of this data outside of it being inside of this particular system. The next configuration we'll dive into here in more detail, where I can specify the tags that are applied to this data, the visibility. So these are the same tags that are present within that access policy we just walked through. And at this point here, what I'm specifying is that PHI is the tag I want to apply to the entire piece of data. So again, remember, we're storing those XML documents at this point here. So the full set of data, single report, is going to be considered to be PHI as a protection to be applied to the entire piece. With this particular setting here, and my access policy being the same one that I just walked through in more detail, what that means is that at this point here, only researchers can actually see the whole document. Any other user that does not have that particular authorization will not be permitted to. Anonymization policies allow us to do some specific types of de-identification. We don't have time to walk through that in this demonstration, but we'll cover that in a different one. Next, I can specify some specific information that helps me keep track of this stuff. Again, there's going to be many different types of data in the system, and it's handy keeping track of properties of it, where it comes from, so I can then manage this data more effectively. The next thing we'll talk about is the data sharing agreement. This allows me to enforce a potential third-party relationship that I might have with someone else who's providing this data, where I can have an electronic link from every single data record in the system to that data sharing agreement, helping me to maintain that compliance along the way in case someone at some point challenges or questions the rights with which that data is being stored in the system. Beyond having that linking back to that electronic document, I can also specify start end period if applicable. What this does is outside of this time period, if set, you cannot access this data within the system. It's still there, it's still being governed, you can still put more data in, but until this period gets updated by the data owner for this particular set of data, the data will not be accessible. Again, helping you be compliant with different restrictions if they happen to apply. The last configuration we'll just mention here, retention type. This allows you to programmatically specify rules for how you want to manage data in the system. So for instance, it may be important for me to delete data after a specific period of time. I can enforce that right here so that when data is put in, I can actually have this enforced through a time to live property associated with the data. And then we have regular periodic processes that run through the system and purge that data from the system. So by specifying these few pieces of information, I can now start putting data into the system. So let's go ahead and do that. Typically, data would be flowing in using an automated process, but in this case here, we're going to actually just show an example of a piece of data. So let me first of all show you what the data looks like. Again, you saw it in the slide, but this is an example of a XML document. As you can see, it has a bunch of information in it, including order dates. We have the name of the individual here, the last name being Cordova and the first name Luis, as well as a bunch of information from the actual glucose test itself. Again, this is entirely fake data, but representative of the type of information. I can take this piece of data, drag it up here into my ingest path, ingest this data into the system, and at this point here, it's now being loaded into the system. All those rules and controls we just talked about are being applied, and now it's stored within the data lake for me to now work with using a variety of different functions that we'll walk through shortly. Couple things to call out here. Again, at this point here, I haven't had to worry about any sort of configurations around how this data is distributed across the cluster, how to restrict access for other users of the cluster. Again, that one screen where I specified who can work with this data is where I configure all of those protections around controlling access to that data. But at this point here, we just have a piece of XML in the system. So this is fantastic for onboarding data. You can do it very efficiently and effectively, which really lets a lot of customers get access to their data more quickly. But let's talk about unlocking that data now. So the way we unlock data in PHEMI Central is through what are called data processing functions. If you're familiar with MapReduce, you can think of this as being like a mapping function. But essentially what it boils down to is we let our customers specify custom parsing functions that will go through and pull out the information from these pieces of data by building these DPFs, as we call them, using common languages like Python or Java. Importantly, developers who are working with this framework do not need to know anything about MapReduce or distributed computing or where the data is in the cluster or how to store the results from it. All of that is taken care of by the PHEMI framework. All you need to focus on is how to unlock the pieces of data from within that particular format of data. We have many libraries that allow you to do this with standard representations such as JSON, XML. For structured data coming from, for instance, a relational database, this is extremely easy and we have automated scripts that can do this. But this is the process where we'll walk through a bit more complicated situation. So down here, we have what are called the digital asset outputs. These are essentially what is this parsing function going to produce. And on the left-hand side, we see all the fields it's pulling out from this particular piece of data. So things like the facility ID, the name, the patient's first name, last name, the primary key associated with this data source, collection dates, etc., etc. In the second column, we see a specification for the sensitivity of the particular value we're pulling out. In this case here, we see a repeat in which the personal health number is being pulled out twice, once with a PHI tag applied to it, and the second time with a de-identify tag applied to it. If I dig into the documentation for this particular data processing function, I'll actually see that de-identify corresponds to a pseudo-identifier being created for the original PHN. That's extremely handy because what it lets me do is I can link on the full proper personal health number if I happen to be a user with access to PHI data, but as a user with access to only de-identify data, I'm still going to be able to link using that common key. Other types of de-identification that are possible include, for instance, naming. So in this case here, the full first name is considered to be PHI, but de-identified data corresponds to masking out of that name. And we'll see this a little bit shortly when we start talking about the analysts who are going to work with this data. One last point to make on the screen here is that it's very powerful and flexible when you don't have to worry about naming your different values differently. Again, all users will refer to this field using the patient first name reference within the analysis they're going to be doing. And it's the access policy that's going to determine whether or not they see the actual PHI value or the de-identified value. I don't have to worry about managing duplicates of data for my analysts. Instead, the system's just going to take care of publishing the appropriate data for them. So that's a brief walkthrough of the configuration that's possible here. I'm now going to switch hats and move over to our analysis perspective to walk through what our two users are going to go. I'm going to begin by opening up a virtual machine running on the cloud that's going to correspond to a Windows machine where my Alice analyst is working here. We see here that she's already created some analysis of the data she's been working with. In this case here, building up a geographical representation of the data along with other statistics corresponding some interesting properties around diabetes conditioning for these individuals compared to their lab reports. If I happen to dive into any of this data here, so for instance picking this date here and drilling down to the information she's actually working with to verify that indeed the protections are in place, I see a little sampling of all the data here. We'll notice the birth dates have all been truncated to the first of the year. So again, protecting that PHI value by removing the actual month and day of the birth date. If I scroll over a little bit further here to some of the other sensitive fields, we see here that the names have also been removed from the data that I have available to me, so they've been masked appropriately. And this gives me the comfort and compliance to make sure that at this point here, as Alice is doing her work, the data she's working with is indeed the data she's supposed to have access to. I don't have to worry about complexities taking place within the actual data lake itself to deal with these compliance issues and access controls. We've got it just configured again within the PHEMI Central system and providing the data for them to work with. The last piece before we switch over to our other user here is you'll notice there's a bunch of states here that don't have any data present for them. I'll explain why that is in 1 second. When I switch over to a new desktop here, where this is Eve, again, a completely different machine, she has built the exact same report. In fact, the two users have actually shared their notebooks, not the data, just the notebooks and the analysis that's being done. And at this point here, Eve has access to a bunch more information and she's able to drill into it. So I can verify, for instance, if I look at the, let's look at the exact same state we looked at previously for Alice. And if we drill down into this information here, we're going to see that here we have access to the full birth date, so including the month and the date. And if I scroll over a little bit to the right here, we'll also see we have access to the full names of these patients, so giving access to that full PHI data. Again, in compliance with the configurations that have been applied. The second piece to draw attention to is you'll notice there are records for some additional geographical regions that were not present before. The reason for this is that we also have the ability, besides just saying you have access to identified or not identified data, we can also restrict the density of data required before you're allowed to work with it. In this particular case here, Eve, with access to full PHI data, can access the full set of records with no concerns because she has received the trust within the organization to do that. So in this case here for the state of Montana, I have 5 records here. If I briefly go back over to my Alice screen here, you'll notice there is no data within the state of Montana. And the reason for that is that we've decided we don't trust her with having that level of granularity of records. In particular, what that means is that by not releasing these records here, instead of always requiring, for instance, that data records correspond to being over a number, and in this case here, the particular threshold is 8, that she will have less of a chance of re-identifying individuals. And even more importantly than Alice potentially doing that is if there was some sort of compromise or breach and someone gained access to the data that Alice has, we don't have to worry about that level of granularity escaping the organization. Again, making it simpler for you to enforce these compliance and risk protocols across the system by making it easy to appropriate and produce the proper data sets as part of that process. So that's been a very brief walkthrough of some of the functionality in PHEMI Central. We've walked through some of the configuration that's possible, how we can easily annotate and protect the data in the system, how we have a powerful framework to unlock this data, and how this ends up boiling down to users who can effectively work with this information to perform their function without necessarily having access to data they shouldn't have access to.